I'd like to welcome you to our April Traverse PC webinar. In March, we started out taking a look at using CAD with TPC, and we covered two things in particular: inserting an XREF into a TPC drawing instead of importing a CAD file, and then calibrating those CAD files to Traverse PC when the coordinate reference systems were different. And that was great. It sort of set us up for kind of a new way of doing things. We don't necessarily just import CAD files into a TPC drawing anymore. And now we want to take a look at two workflows. Today we want to talk about CAD Export Workflows, and in May we're going to take a look at CAD Import Workflows. And I want to focus in on this unified help system. Now, generally in these webinars, I work right out of the outline in the webinar registration, but I want to do something a little differently here. I'm going to go to the member area and bring up the Learning Center. And the very first link in the upper left corner is the Unified Help System. Let's go ahead and bring that up. And we're going to camp out here instead today. And I want us to drop down to Using CAD, and here are those two workflows: CAD Export Workflows, CAD Import Workflows. So we're going to focus on the CAD Export Workflows today. So in this topic, we talk about what are the things that we do as far as exporting CAD files from Traverse PC. So Traverse PC isn't a CAD program necessarily, but we do our drawings. And then we talk to CAD or communicate with CAD as needed for importing and exporting. So when I'm thinking about what I'm going to do with these CAD files, I generally will come ask some questions. And I do this pretty much for every job that I use Traverse PC on that involves CAD. And here are the questions I ask. For this project, am I just exporting a one-off CAD drawing? Do I just need to export a DWG file to somebody that needs it for whatever, an architect, an engineer, city planning? Number two, am I required or requested to update an existing CAD file? Is there a CAD file or a series of CAD files we're using for a project that's ongoing, and I just need to add some data to it? Number three, is Civil 3D being used, and do I need to use Land XML? Number four, do my survey grid and CAD project grid match? In other words, are they using the same coordinate reference system, or are they different? Do I need to provide a certain version of CAD file for number four? And then number five, and then number six, what CAD file types do I need to use? DWG, DXF, DXB, DGN. And depending on how I answer these questions, I'm going to choose one of these five workflows. And I just want to look at these really quick. The first is we're going to export a TPC drawing to a one-off or a new CAD file. So we're going to create a new CAD file, either in our coordinate survey reference system or in one that matches an existing CAD file. Number two workflow, we're going to take a look at exporting specific layers and objects from a TPC drawing to a one-off CAD file. Number three, we're going to take a look at exporting specific layers and objects from a TPC drawing to an existing CAD file. Number four, we're going to take a look at exporting via Land XML for Civil 3D. And then last of all, exporting a CAD file specific to my data collector or controller. So let's just jump right in. We're going to start here with this very first workflow, and all five of these are listed below. And if I drop into any one of these, I want you to watch the table of contents on the left here. So four of these are listed here, and the Land XML one goes to the Land XML portion in the table of contents. So these are subcategories under the CAD Export Workflow, and we're going to look at each one of these individually. So let's take a look at the first one: exporting a TPC drawing to a one-off CAD file. Now, for many projects, you deliver just a single CAD file, and that's what we're calling a one-off CAD file. So this is typical of a site survey you might do for a client. Send them a CAD file, or send the CAD file to their architect or engineer or some local planning department as part of our permitting process. It's kind of a one and done. The coordinate reference system may or may not be specified. Oftentimes it's not, so it doesn't matter if I'm on state plane or a low distortion grid of some kind or at 10,000, 10,000. And then sometimes the most critical component of this is exporting a version of CAD that the client's architect can open. A lot of them still use older copies of AutoCAD. So when I work with an architect for a client, I'll just say, hey, I'm going to send you an ASCII file, a PDF file, and a CAD file. Do you want DWG? And if so, what version do you want? So that's real typical. So let's go ahead and drop down into this one. And this is how we've set up these workflows inside of Traverse PC. Each workflow has its own separate page. So we're just going to drop down into this one for exporting a TPC drawing to a one-off CAD file. We talked about these common workflows, and let's just jump right in. So the first thing we're going to look at is exporting a one-off TPC drawing to a CAD without calibration. So by default, Traverse PC uses the coordinates of your drawing to export CAD files. If you were to list a specific entity or object in the CAD file that TPC creates, it'll have the same coordinates as it does in your TPC drawing. Okay. And you can export any of the supported versions and file types like DWG, DXF, and DGN. So let's just take a look at one of these. Let's drop into exporting DWG files. So here's the help topic on how we do that, what that looks like. And I'll go ahead and expand this to make it as large as possible. And I don't normally do this, but for this webinar, I want to just play some of these videos that you're going to see as you walk through this yourself. And I've got the system sound turned on. So, and I like to do this because these videos can zoom in. They've got the little yellow cursor you can follow. I think it's a little easier to follow along. So in this example, we're just going to say, I just want to export one of my Traverse PC drawings to a CAD file and take a look at it. It's real short, just 1:52. Let's go ahead and run that.
Let's do the same thing now by writing a DWG file. So I'm going to right click. This time I'm going to choose Tools, Export Drawing As. And we're going to see there are a number of ways that I can export this drawing as a shape file, as an image file. In this case, I want to write an AutoCAD DWG. I'm going to click on the Settings button, and I see that I can choose any number of different AutoCAD formats. I want 3D lines. There are other options I can choose, but that's enough. Let's go ahead and export. Traverse PC writes the file and tells me it's finished. I'm going to click the Preview button here because I want to take a look at what I've just written. On this computer, I don't have a copy of AutoCAD, but I do have a copy of the Bentley Viewer. So the Bentley Viewer is going to open that DWG file for us, and we're going to see what it looks like. Once inside the viewer, let's go ahead and maximize that same drawing. And let's go ahead and display the layers that Traverse PC wrote. I like to show the layers and then remind you that Traverse PC writes this drawing as if it had been developed in a CAD program. So we have layers, we have blocks for the symbols, we have hatching for the fills. If we had a background photo, it would come in as a raster image. The paragraphs of text come in as paragraphs of text. So everything can be manipulated or used inside of the CAD program as if it had been generated by a CAD program. So it's more than just a pretty picture. We actually have useful objects inside the CAD program. Traverse PC is looking out for the people that you're going to send this information to, knowing that many of them are going to be using them inside of a CAD program.
Okay, let's go ahead and come back to our view here. That's really, really simple. Just a simple look at writing a DWG file. Let's take a look at an example that exports a surface. Again, it's just a couple of minutes, and let's get a better feel for the richness of the CAD files that Traverse PC writes.
In this video, that's part of our topographic workflow, let's go ahead and export this surface to AutoCAD, just to kind of see what Traverse PC does with it. So I'm going to right-click, choose Tools, Export Drawing As, and I'm going to choose AutoCAD DWG. I really don't need any settings, but you can come in and choose which version of AutoCAD you want to export as. And then I'm just going to say, go ahead and export that. Let's overwrite the file I sent earlier. And I've got a preview button set in the settings, so it automatically brings it up inside of AutoCAD. And this is the AutoCAD viewer, so it's not even the full version of AutoCAD. So here's my drawing that I brought over, and you can see the tin and the contour lines there that are part of the surface that we exported. Let's go ahead and just put this in orbit mode here. And let's just kind of bring this up so you can see what we got here. Can you see this surface pretty readily? So Traverse PC brought that in three dimension. That's what it developed it in. And you can start seeing now a little bit about how steep that was. And I want you to know that this is a polyface mesh. I think in DGN it's a polygon mesh, if I have my nomenclature right. So it's as if I had developed this surface inside of CAD. And that's kind of neat because if I'm going to use this for engineering, I need that polyface mesh available to me, and it is. So it doesn't matter if we develop this surface in a program like Traverse PC or in Civil 3D or whatever, I get the same polyface mesh. And I can work on it now inside CAD however I want. So this is a pretty neat deal. We often talk about the fact that Traverse PC plays nicely with CAD. And when you send someone a CAD file, it's a rich CAD file. And you're seeing just a little piece of that here. That here I've got 3D on these lines here. I could have turned that 3D option off or just set the elevations to 0. That would have been fine. So they're kind of up in the air also. But I did want you to see this polyface mesh and the fact that I've got something pretty nice to work with inside of AutoCAD.
Okay, I'm going to stop there. There's a lot of information on writing DWG, DGN, all those files, and these sort of one-off CAD files. So you're going to find all of that in here. And a lot of you have been doing this for years, and you know that these really are pretty rich files, and that I've got the opportunity inside Traverse PC to set the settings that I want for those files and the versions that I want for those files. And a lot of the work I do is just, I mean, that's the extent I interface with CAD. I finish my drawing in Traverse PC, I send the client a PDF, and I fire off a PDF and a DWG to their architect or their engineer. So pretty simple. Now, we've got a webinar we did on deliverables. I just want to bring that up real quick, where we took a site survey and one that we had done and said, let's walk through how we delivered this for the client. So this was a landowner here in town that had some property that he subdivided for his kids and eventually for his grandkids. And this is one of the lots out there that the family wanted surveyed. So we started out with a site survey and basically said, let's pick up all the utilities, the topo, the boundaries, and we called the architect and said, okay, we're going to send you an ASCII point file, we're going to send you a PDF of the site survey, and we're going to send you a DWG of the drawing. What version do you want? And if I remember right, he wanted AutoCAD 2012 because that's what he was still using for his architectural work. So then we just walked through the pieces. We walked through what it took to send him off that ASCII file so he has all the points to work with. The PDF file, so he's got a picture of what we did in a PDF format. And then the CAD file we send him, so he's got the DWG or DGN, whatever format he wants. And then we also just touched briefly on writing a land XML file for clients or architecture engineers that are using Civil 3D, where that comes into play. So you're going to find some great information there in that webinar on deliverables, and it'll kind of reinforce some of what I'm talking about here. Okay, so that's a one-off file, and neither one of those involved calibrations. Okay, but let's take a look at calibrating our export to CAD. And I want to drop right into this calibrating a CAD file here. And we've got a short video that's just under 3 minutes. And I want you to pick up on the fact that the CAD file we're working with, and these are all metric files from a Canadian user, the CAD file we're working with is not on the same coordinate reference system as our survey. It's close, but it's not quite. And so we're going to calibrate that CAD file when we bring it as an XREF so that it matches our survey. just watch now and you can kind of get a feel for what we're talking about.
In this video, let's take a look at exporting a CAD file using a calibration. So I inserted this XREF, and I previously created a calibration file for that called CAD.cal, and it's saved in the folder with the survey. So I can simply say, apply that calibration, and it moves that XREF appropriately so that it fits my survey. So I've got the XREF or the CAD file in one coordinate system and my survey in another. If I were to come over to this XREF, I open it up in the CAD view here, and let's take a look at properties for this little arc here. I could copy these coordinates, and I see it ends in 521.114 and 946.638 for the X and the Y. And if I take a look at my arc over here, or the properties of that, I'm in my survey coordinate system. So I've got different beginning and end points that are not the same as they were in the CAD view. So let's go ahead and tell Traverse PC that I want to export this drawing back to the CAD client, and I want it to be in that original coordinate system that the CAD file was in. So watch how we do that. I'm going to say Tools, Export Drawing As. I'm going to write a DWG, and I'm going to choose Calibrate and select that same CAD file. So let's go ahead and pull that out of the folder. And it tells me the original calibration went from the DWG to my survey, my local survey. So I want to reverse that. I want to go from my survey to that original CAD file system. So I'm going to say, okay, let's go ahead and export this. Okay, Traverse PC overwrites that original file that was there. Now I'm going to tell Traverse PC I want to preview that in the CAD view. And let's go ahead and zoom in on that now. And let's do the same thing we did earlier. So now I'm going to select that arc, go to Properties, and if I zoom in on this, here's my 521.114 for the X and 946.638 for the Y. So I have the same exact coordinate system for this CAD file that the original XREF had. So I can work with one coordinate system in my survey, and I can send a CAD file back to an architect, to an engineer, or whoever, right back in their same coordinate system, simply by reversing a previous calibration that I set up, going from one of their CAD files to my survey. So really...
Okay, did you kind of catch the drift of all that? That here I have a CAD file in one coordinate reference system and my survey in another. And that happens a lot for various reasons. And I'm just using the calibration to coordinate those two, and it's not a problem for Traverse PC. If I want to send them a file in their CAD or project coordinate system, I just reverse calibrate, and away it goes. So there's plenty of information here. You can kind of read up on it, find out about it. And that's exporting a one-off TPC drawing to CAD with calibration. Okay, so we just covered the first workflow, exporting a TPC drawing to a one-off CAD file. Let's drop down to the second one now, exporting specific layers and objects to a one-off CAD file. So take a look at this. But what if we don't want to include the entire drawing? We want to send just selected layers or objects. And this is real common in planning processes. So the planning process for a project oftentimes requires that a number of drawings be submitted for different aspects of the project. For example, a site plan, a grading plan, a vegetation plan, some profiles of cross sections, easements, and so on. So a lot of times it's not uncommon for me to have a dozen drawings or so or more by the time we get final approval for a project. And Traverse PC can have any number of drawings, so it makes this workflow really easy to accomplish. So just like we did with the last one, let's drop in to the topic that's dedicated for this workflow. It's a subtopic of export workflows. And let's take a look at managing layers first. So we can freeze layers, we can turn layers on or off, and we can reduce the amount of information that gets exported or that's visible when it gets exported so that it's easier for someone to pick up that drawing and go, yeah, that's the vegetation plan that I needed, or that's the drainage plan that I needed, and not have to wade through everything that's in that drawing. So I'm going to drop down into this Manage Layers. I don't have a video here for you, but I want you to just see that we talk about 3 methods to managing layers. You can use a layer dialog box, the drawing data manager, and the drawing view. And then we get quite a bit of information on this exporting layers and the options for that. And I don't know how many of you are familiar with this, but when Traverse PC writes a CAD file, it uses the same layers it does internally. So I've got all my point labels are on the TPC point labels layer, and all the lines are on the TPC lines. Symbols are on TPC symbols. But each traverse can also have a layer name, and Traverse PC can combine the two. And we talk about that here. So if I use a traverse layer name that says lots dash asterisk, the asterisk says replace that asterisk with the normal layers like TPC symbols. So I could have layers stratified for lots dash TPC symbols, lots dash TPC lines, lots dash TPC point labels. Okay, I can reverse that, put those first, TPC symbols dash lots. If I leave the traverse layer name blank, I just use the entity names. And I should have added one more down here that says if I use the traverse layer name without an asterisk, everything just goes over on that traverse layer name. So I do this all the time when I'm exporting as-builts. I want the as-builts to go on an as-built layer. So I go into that traverse where I've collected my as-built locations, and I just set the layer name for that traverse to as-builts. Or sometimes I'll say as-builts dash 4-28-2022. So those are the as-builts I collected today for that project, and it puts those on that layer. So everything goes on that layer. Symbols, labels, lines, okay, fills. And it's a great way for me to control what kind of layers get exported to a CAD file. So Traverse PC gives me some great tools for managing layers. And I often can get exactly what I want out of those. So we talk about managing layers and those export layer options. And of course, I can always freeze layers. I can always turn layers off. The big difference there is that if I turn a layer off and I open that CAD file, the layer is turned off, but I can turn it back on. If I've frozen a layer in Traverse PC and export a CAD file, it doesn't create any entities for that layer. So I can open that layer in the CAD file, but there won't be anything on it because Traverse PC froze that. So you might want to go in and just kind of look at those differences and learn those differences and make sure you're doing exactly what you want on those. So managing layers is one. Duplicating drawings is another one. And this is a really slick thing inside Traverse PC. I'm going to just play this short video here, just over 3 minutes. For those of you that aren't familiar with duplicating drawings, I think this will kind of open your eyes and say, wow, a lot of times I could do this and create alternates that I want to look at. And we're going to just do that real quickly here in this video. So watch with me.
In this video, let's take a look at duplicating a drawing. So in a previous video, I started this Lot 10 development drawing that's identified down here. And let's just go ahead and throw some text in here in paper space. I'm going to choose some black text. Make this pretty large. Use an Arial. That's great. And I'll do bold here. So let's just put in some text. And let's say design concept A. So I've got a design concept A, and we're going to show some possible designs on this lot. But I want an alternate, or a B, in this particular case. So I can come down to this drawing, and I'm probably going to rename that to A, like that, just so I know which one it is. Okay, I'm going to right-click it, and I'm going to say I want to duplicate that drawing. And Traverse PC gives me a drawing name dialog, and I'm going to remove the duplicate, Lot A, and I'm going to call this Lot 10 Development B. Now, I'm not being real creative here. I'm just kind of creating another drawing. And then Traverse PC says, I've duplicated that. Would you like me to open that for you? And I'm going to say yes. So I now have my duplicate drawing open. And let's do a couple of things right off the bat. Let's first edit this Concept A text. Go to Properties, and let's tell Traverse PC to use Concept B, just to kind of keep it straight. If you notice, Traverse PC added that drawing to the unassigned group. So we're going to right-click, choose Drawing Groups, move that to an existing group. We already have a development group, so we're going to say I want to put it in that group, and it moves it down in my development group. And I'm going to collapse all the groups but this one, just so we can kind of see how that works. Okay, so now I've got Development A, Development B. So if I double-click Development A, here's my Concept A. If I double-click the Development B drawing, here's my Concept B. The duplicate drawing starts with everything that was in the original drawing. And I can then delete things that I don't want. So if I don't want to have a scale bar in this one, I can just delete it. It's now not in this drawing. But I haven't modified the original drawing, Development A. It's still however I left it. So duplicating drawings can be a great way to say, you know, I've got pretty much what I need, but I want to show an alternate to that, or I want to continue this drawing in a different direction. Just make a duplicate of it. Everything that I had in paper space, survey space, the tag traverses, those all show up in the duplicate just like they did in the original.
Okay, so to some of you, those duplicate drawings are a new thing. I use them all the time. So we give you some great information about how to create those, how to manage those. And a lot of times you're going to find that duplicating a drawing is all you need. Now, because this is not a drawing you're using for other purposes, well, I just talk about another option to export specific layers or objects is to duplicate an existing drawing specifically for that purpose. And because you're not using it for other purposes, you can actually kind of take some liberties here. You can delete layers you don't want. You can delete objects you don't want on layers you otherwise want to keep. You can untag traverses you don't want so they're not drawn. So I've got a drawing that I've duplicated, and I've got a specific purpose for it, so I can really do whatever I want, and I'm not affecting the other drawings in the survey. So really a great, great tool. We've got another webinar we did a while back on planning workflows, and I'm not going to watch it because it's an hour long, but I just want you to see that we took one of these planning projects that started out as a site survey. Okay, so we just spend 4 minutes in this hour about putting together the site survey, but this was for a parking lot project, half a block in Florence here. And it was interesting, like a lot of these projects, before we're done, we've ended up with all the parking lot layout, okay, so that we have the number of spaces and bicycle parking, all that kind of stuff. We have drawings for grading and drainage. We have drawings for pavement and curbing. We have drawings for bioswales and landscaping. We have drawings for overhead lighting. And then we have drawings for the construction phases that we had to get approval from the city for. So you end up with quite a few drawings in here, and we kind of cover how that works. How do I manage all those, keep track of all those, do revisions for all those? Traverse PC does just a great job with those. And if you're involved in those kinds of projects, this would be a great place to just come and spend an hour and watch how we do those. So planning workflows is there. Now, this is another part of this workflow that I think is going to be real important. So we've covered managing layers, duplicating drawings, giving you some examples. I want to now talk about exporting a single traverse drawing. And I don't know how many of you are familiar with this tool. I use it all the time. So I've got a whole survey with all the different drawings in it, but I just want to look at one particular traverse for whatever reason. In Lane County, when I submit a subdivision, I also have to have a separate drawing for each lot in the subdivision. A lot submitted to the county. A lot of you do legal descriptions, and you want a legal description written out. Traverse PC does that for you, and you also want a picture of that boundary or whatever you're describing to go with it. Well, I could do that real easily out of this, viewing a single traverse. So let's just drop into that. Now we have quite a bit of information for it here, but I want you to just watch a quick video, 6 minutes long. I'm going to show you kind of what that looks like and when and how it's advantageous for us. So let's take a look.
In this video, I want to take a look at viewing a single traverse. I'm going to create a situation where it's advantageous to me to do that and then show you how that works. So this is an example we've used for some of our XREF examples, and I'm going to come in and turn off that calibration so you can see that the XREF I brought in was actually not quite lined up with my survey here. And then I want to right-click that XREF, and from the XREF tools, say open that in the CAD view. So now you can see over here in the CAD view that this is the original XREF we started with, and I'll kind of zoom in about that same area just so you can see what we got here. So let's say that the contractor has called us and said, you know, I need some of these points here in this center of this street here because they're doing some excavation and I just need to know they're doing it in the right place. So we're just going to go out and pick up some of those points. So I'm going to pick this back as calibrated again, calibrate that and choose OK. Yeah, so now we're back in line. So let's go ahead and create a traverse here with some of these points in here. I'm going to do that with the add points to a traverse. I'm going to call these excavation 4/21/2022. I like to put these new traverses into groups, so I've got a group called as-built. I'm going to add it to that. My traverse view format is just going to be coordinates, and the way I'm going to draw that is with imported points. And I can go in and say, you know, those are the basic settings, but I'm also going to want to do elevations and descriptions, and I'll show you why in just a minute. And I'll probably want these things to be just a little bit larger. The third option here allows me just to create points wherever I click, and that's how I'm going to do these. Let's call these EX1. Let's put a description in here that says top of cut TLC. And we're going to tell Traverse PC we want to leave the traverse view open when we're done. So the first point we create is going to be EX1, then EX2, EX3. Now I'm going to click on these with the mouse here, but you could just as easily have gone out with GNS, GPS, and picked up the top of these slopes, or robotic total station, or whatever you're using. I'm just going to create several points here. And let's say that that's really all I need. I'm following the prompts for this command, so when I'm done, I press enter, and I've got my points here, and I've got the points in a traverse. So let's come over here and let's crunch those down to a single row. And I'm going to simulate the elevations. Either I ran a level through those afterwards, or I picked up elevations as I went. 14, let's come back to 13 here. So I've got this traverse, and what I'd like to do, I'd like to send these points back over to the drawing they sent me. Okay, so I'm going to update that drawing with these locations. They're going to come over on their layers with their labels and symbols. And I'm going to send this file back, or maybe this file is on a cloud drive and we all have access to it. So here's the command I want to use. Draw just this traverse, or you can go to Tools. It says draw this traverse only. Let's go ahead and click that. And if I hit Zoom Extents, I see here's just those traverse points. Now, the reason this is helpful for me in this situation is that I don't want to send all the traverses and all the points over. I want to send just these that I've got selected here, but they're going to come over on some different layers, point symbols, point labels, layers, and I don't want all of those for the whole survey. I just want it for this one traverse. That's why I've come in here and selected just this one traverse. Could have used an empty drawing, that would have been better. Watch what I'm going to do. I'm going to select, and I'm going to do a cross selection. So whatever I cross here gets selected. So those points are now selected. Now I'm going to right-click any one of them, and this is the command I want, CAD view, and I can send a selected object, but if I miss one of those, I could go to the layers. So that would work. I mean, I'm just doing this drawing, those layers. So maybe I want to send the layers, and that way I'll get everything from this drawing that's on the point symbols layer, everything from this drawing on the point labels layer, and I'm just going to hit OK. Now, in some other videos, we've talked about calibrations, and you saw me recalibrate that XREF to my survey. Well, I don't want to send my survey coordinates back to their drawing because it's not the same coordinate reference system. I actually want to reverse that and go from my survey back to their drawing file calibration. And that's what this is asking, saying, do you want to do that calibration for the associated file? I'm going to say yes. So look what happens. Traverse PC goes ahead and brings those points in exactly where they should be. So based on the coordinate reference system for the DWG file, not for, now as soon as I close that traverse, it says you want to keep that single drawing, single traverse drawing. I'm going to say no. I go back to my whole big drawing here. And I see that because I had actually had to calibrate this drawing to my survey, if I had sent these points back on reverse calibrated, they would be in the wrong position. But the way I did it, they're exactly where I want them. I simply go into File, choose Save CAD File. I've updated the file, and away I go. So that's where using that ability to draw a traverse, a single traverse in the drawing is really helpful to get just the information I want back to the CAD drawing.
Okay, kind of neat, isn't it? So I can actually update an existing file using the reverse calibration. And that's a great segue into our next workflow. So we're kind of done with this one now. I've exported a single traverse as a drawing. We talked about exporting calibrated versus uncalibrated, and you can drop in and get some more information on that, kind of see how that works. Here's a shorter video using that same example survey. But you get an idea that, wow, I can do these workflows that I want with that one-off file. So now I want to come down and take a look at the third workflow, exporting specific objects to an existing CAD file. This is kind of neat. I'm going to take a look at this. So you can export specific objects from a drawing, TPC drawing, to an existing CAD file, which in essence updates the CAD file. So the difference here is to an existing file, not to a new one. So what kind of workflows are we looking at here? This workflow can happen on a planning or construction project where you're asked to provide additional information as the project progresses. This option allows you to update one or more existing CAD files directly. You can also send the information via land.xml or a separate drawing and let someone else merge the data, but what if you could do it yourself and make sure that it comes in the right place? So let's drop down into this third one here and take a look. I want to start with this benefits of updating an existing CAD file. So when you export a TPC drawing to CAD, TPC creates a new one-off CAD file for that drawing that contains just the layers, entities, blocks, hatching, raster images, surfaces, etc. for that Traverse PC drawing. If you choose an existing file name, when you export, TPC will prompt you to overwrite that existing file with a new one. So any information that was previously stored in that original file will be gone. When you update an existing file, that file continues to contain all of its original information, plus any new elements you have added to it. So that's the big difference. I want to keep whatever was in that CAD file, maybe from other applications, and I just want to add my own to it. So let's take a look at sending drawing objects to that CAD file via the CAD view. I just open any CAD file from any architect, engineer, or planner in the CAD view. I add my survey objects, and then I save the CAD file from the CAD view to update it. Pretty simple, okay? That's it. And I want to drop in and take a look at that here. So sending drawing view objects to the CAD view. And we're going to drop into another part of the table of contents here where we talk about that in another area. And we've got quite a bit of information on it here. But I want to just take a look at this short video, just under 3 minutes. This is Fred Meyer's store that came into Florence here. Later, Fred Meyer was bought out by Kroger. So a lot of you are familiar with the Kroger brand. But this was a new size, a store, 90,000 square feet they hadn't built before. So it was a new set of plans, hot off the press. We did all the original boundary survey and then the construction surveying for it. And boy, we went back and forth a lot of times with the architects just for mistakes that were in it because they just hadn't used this plan before. But I just want to show you how easy it is for us to say, you know what, we're just going to add something back into their CAD file. So let's take a look at this.
Welcome to the TPC Desktop video series. In this video, we'll look at sending objects from the drawing view to a CAD drawing directly inside a Traverse PC. This is a feature that's new in TPC Desktop 2016, and we'll do this using the CAD view. So I've opened up the Learn Import CAD sample file that ships with the program, and I'm going to open up the CAD view and tell it I want to open up the DWG that we've been using, a couple of the videos. We converted a DXF to a DWG, and I'm opening that DWG now. So I've got a drawing, a database, and I want to come back to this drawing, and just to keep it simple here, I want to send this survey boundary over to the drawing. Now, I certainly could tell Traverse PC under the Tools, Export Drawing As, to write any number of formats, an AutoCAD DWG, and I can come in and pick the version that I want, etc. And I could write a file and then somehow merge that into this CAD file if I have those tools in AutoCAD. But it's real easy for me just to do it right from here. So I'm going to tell Traverse PC I want to select some objects. I'm going to window the objects I want, and I'm really picking the graphic objects here. So I've selected the objects here. I'm going to right-click any blank spot and go down to Tools, and I want this command right here, Send Selected Entities to CAD View. So I've got the CAD View open, I've got a CAD drawing open. I'm just going to send those over now. So Traverse PC tells me the number of entities that were moved, 48 out of 48. So all of them were good candidates for this. And look at my CAD view now. So I've got my survey boundary in this drawing, and I could come in and take a look at it and say, well, what is this here? Let's take a look at what this is. I've got some text here on TPC point labels. So I've got some TPC layers in here, and I could come in and isolate those then. Let's select all, turn them off, and then I've got some of these TPC layers in here. So TPC lines, TPC labels, TPC symbols, let's turn those back on. And you can see here's the boundary that I sent over with whatever line labels, point labels, symbols, line types I had in the drawing. We can come back here and select all and turn everything back on. So this is just another, I think, real simple way, real easy way for me to send whatever survey information I want over to this CAD drawing, take a look at it, make sure I got what I want, and then just choose File, Save CAD File, and now that's available to anyone else who opens this CAD file in whatever CAD program they're using.
Okay, so you get the idea that I can update an existing CAD file right inside our CAD view. Now the CAD view doesn't have a lot of CAD tools. I'm not going to use it for designing and drawing, but it allows me to do these kinds of things really, really simply. Open any CAD file, convert it to a different format, or add some survey information to it and save it. Just real simple to use, and we've done it in this particular case without any calibration involved. Remember, we supplied the original survey information for this project, and they designed it on our coordinate grid. So when we got the designs back, they were ready for stakeout, which was great. But we've talked in this webinar about doing this calibrated and uncalibrated both, and we understand it's really not a difficult thing to account for the differences in the coordinate reference systems now. So a lot of information here on sending objects, on using calibrations. I'm just wondering if maybe we should hit one more calibration thing here, just so we can kind of get a feel for it. Let's do that. This is 5 minutes, but I think it's worth our time. Let's drop in.
Welcome to the TPC Desktop video series. In this video, we're going to look at Calibration Associations, where calibration can be associated, in this case, to a CAD file. So I'm using the XREF that we used in the Calibrate XREF video, and I've selected 4 of these point pairs. In this case, here I've got the end of a line in the XREF to a point in my survey, another one up here. So I'm going to right-click to tell it I'm all done selecting those. I'm going to tell the calibration I'm going from that DWG XREF file to my local site. Okay. Here are the points that I selected. Here's the parameters that it computed. And in just a moment, we're going to come back and take a look at this list here, because we're going to see that Traverse PC is going to add this DWG file as one of these XREFs. So let's go ahead and save that. Okay, I'm going to put the cursor over the XREF, go to X References in the pop-up menu, and then open that in the CAD view. It's a new tool in there so that we can easily get access to the XREF that we're using here. Now, if I bring up the Manage Calibrations and take a look at this calibration that's here, I'm going to see that Traverse PC has associated this DWG file with this calibration. So this calibration was created by going from the DWG file to my drawing view, or to our survey's coordinate system, and that's called a forward calibration. It also knows that I could do a reverse calibration from the drawing back to the CAD file, and we're going to do that in just a minute. So Traverse PC is smart enough to go both ways once it has associated this CAD file with the calibration. So let's cancel that, cancel this. Let's take an example of it. So I'm going to, let's zoom in here just a little tighter, I think, on this corner. Okay, I'm going to send this text over. So let's go to CAD View, Send Object. Traverse PC says, hey, I found a calibration that's associated with the CAD file that's opened in the CAD view. Do you want to use that calibration and when we send this data over? And I'm going to say yes. It's also going to tell me that if I hide this box, I can find it again under View Calibrations inside the CAD view. So I'm going to say yes, use the calibration. So it sent it over based on the calibrated position, reverse calibrated position in the CAD file. So let's do the same thing with a line, just so I can see something a little more exact and get a feel for kind of how it's doing this and what it's doing. So I've just added this line, this long chord, and if I need that back in the CAD file, I'm going to do the same thing. CAD View, send the object. I'm still showing this box, so I could turn this off and it would happen automatically. I'm going to say yes. See what it did? Brought it right in where it needs to be. I'm going to do that again, but I'm going to say this time don't use that reverse calibration. So let's send this line again. Let's CAD View, Send Object. This time I'm going to say no. So I want to send it back without recalibrating. So it's going to send back Traverse PC's coordinates, not the CAD file's coordinates. Let's watch. See what it did? So I want you to see real quickly that Traverse PC can set this up for me, and I can start using this to work back and forth between my survey and the information in the CAD file. I'm going to delete these here real quick, and I'm going to show you then what I would do. Let's select this one and delete it. Yeah, under kind of a production mode, I would say, okay, I'm going to send the first object over, and I'm going to say CAD View, Send Object. I'm going to tell it, don't show me this again, and yes, use the calibration. Now I can send any additional objects over here, and they just show up. If I were to come into this CAD view and have some additional objects that I wanted to send over, and let's have that just touch that, and I'm going to send this object back now over to the drawing view. I have to select objects first. Okay, so let's drawing view, send selected entities. See how it came in the same position? So I used a forward calibration there to go from the CAD view to the drawing, and to send that long chord and that arc definition text I use the reverse calibration. That all happens automatically, and I can come into View, Show Calibrations, and tell it I want to continue to use that association or not. When I save this survey, it'll save that calibration of that association with the survey, and it's also in that cal file. So I can share that calibration file and use it with any number of other surveys on this project, as long as the CAD files continue to be in their coordinate system and Traverse PC continues to be in its coordinate system. So this is great. I mean, how many times do I get a CAD file that's in inches, not feet, or based on local site when I'm in state plane? Just all kinds of reasons that they're not on the same grid. And this says, hey, that's not a problem. I can work back and forth between the two of them with a calibration.
Okay, I'm so glad you get to kind of see how that works and get a feel for the fact that, yeah, I can see how I can work between a CAD file and my survey when they're on the same grid and when they're not on the same grid, and how this calibration stuff just kind of takes all the busy work out of it. Now, I want to just extend that a little bit. So in the last video, you saw me sending some objects back and forth between the CAD view and the drawing view. What happens if they're not that close? And I'm going to show you an example of that. So in that previous example, I could send them, and they were pretty much next to each other, but they were off, and I could see it got calibrated or uncalibrated. I want to show you a tool that we've just added that's coming out in TBC 22 R1, due out June of 22, where we've got, we need to have some more tools to coordinate these coordinate reference systems between the CAD file that we're working with and its coordinate reference system, and our survey and its coordinate reference system. And this will be real obvious, and you'll see how we take care of it inside Traverse PC. So this is 7 minutes, but I think it's worth taking a look at here.
Let's take a look at a new calibration tool available early summer of 2022 in TPC Desktop 2022 Release 1. So this is a project I did a couple years ago, and I needed to have a lighting design done for half of a city block for the parking we were putting in. And so I sent the property boundary, the paving edge, I had the striping turned on in here, to Hubble Lighting, and said, this is what I need for dark sky compliance, minimum lumens, that sort of thing, per the city requirements. And my project is in state plane. So I sent them a CAD file with state plane coordinates. I want to come over here and show you what they sent back to me, this particular iteration. In fact, we went through several lighting plans, and all of them were the same thing. They sent me back a file with coordinates 0, 0. So they got my layout, and you can see everything is laid out here. The property line, the edge of paving, the striping that I gave them in state plane, and they translated it to 0, 0 to work properly, I'm guessing, with their lighting design software. Now, I didn't know if they had rotated it, scaled it, translated it, what all they had done. The first thing that I did is I said, well, this is going to be interesting. So if I were to insert that as an XREF, which is kind of how we do things now, we don't just bring them into the drawing, we just insert them as an XREF, and do a zoom extents, I'm now going to have two dots. This dot is my survey at state plane coordinates. This dot is the Hubble lighting design at 0, 0. Now, I could translate the 0, 0 over to my survey. I could also calibrate it over, but I'd have to do some zooming, zoom windows, zoom extents, that kind of stuff. And again, remember, I didn't know if they had rotated and scaled it as well. So I could have spent hours on the phone or a couple of days emailing back and forth, but I'm going to show you what was easier to do. It was easier for me just to calibrate this to my survey. Now, that's great. This happens to be a lighting plan from Hubble Lighting at 0, 0, but how oftentimes do I get plans from an architect at quarter scale, 4 feet to the inch? Or how often am I working with my survey at state plane projection, and I get a CAD file for the project at ground elevation. So now I've got to reconcile grid to ground. So the reconciliation, the calibration can be large, as it is in this extent, or it could be pretty small. Sometimes that grid to ground stuff isn't that big necessarily, but we have to account for it. So let me show you how we do this. I'm going to come up and choose Tools, Calibration, Create Calibration. And this is the option I want right here in the middle. Select uncalibrated point sequence from the CAD view, then select their calibrated positions in the current drawing. Okay, so I've opened this file in the CAD view. As soon as I choose OK, Traverse BC says the CAD view is now active. And Traverse BC turns on snapping. You see the little yellow there at the cursor? So I'm going to use the property line, and I'm going to come over and select that corner of the property line right there. That tells me that's point 1. Let's get that corner, point 2. Let's pan down to the southern end. And calibrations work best if I try to encompass the area I'm working on. So I don't want to have my points right close together necessarily. I want to feel like I'm picking up a reasonable proximity for the whole project here. And then the prompt says, right click when I've selected the points. I'm going to right click, and it says now the drawing view is active. So now I can come over in the drawing view and I can snap to those same corners, and you'll see if I zoomed in, it's labeling those for me. I'm just snapping to each of the same corners in the same sequence. Now, as soon as I've snapped the 4th point in the drawing view, because there were 4 points in the CAD view, Traverse BC says, oh, that calibration's done. So here's my calibration results. Here are the 4 points. I can see that they got included. There are 4 pairs. My results say this TX and TY, that's my translation. Here's how much I translated it. And then I'm going to just look at the rotation and scale. So Hubble didn't rotate and they didn't scale this. So they just did a translation is all. Now, I'm going to have you notice that because I started with the CAD file to create this calibration, Traverse BC has referenced that file to the calibration, and that's important. We'll come back and look at that in just a moment. So I'm just going to make some notes here that I'm going from CAD to my coordinate reference system. And this is the crossroads parking. And I'm going to call this Hubble lighting. Okay, let's go ahead and save that. And I saved it earlier, so I'm just going to overwrite that same calibration file, just like that. So now let's do what we did earlier. Let's bring this in as an XREF, and I'm going to turn off or untag that Traverse with the lighting so we can see what Traverse BC is going to bring in. Yep, that'll work. Okay, let's do Insert, XREF. Let's pull in that same file now, double click it, and look what Traverse BC says. A calibration association was found. Calibrate the XREF with the associated calibration, yes or no? And it's Hubble lighting. So let's say yes. So Traverse BC is going to bring that XREF in now, and it's going to calibrate everything for me based on that calibration that I just created. Wow. Wow. Remember I said I went through several iterations for lighting with Hubble. I would have had to go through that translate, rotate, scale each time I got a plan from them, not knowing what coordinates they had put it at. So think of the mess that would have been. Here, it's just easy to say, well, I'm just going to pick the 4 points in the CAD file, the lighting plan, and the same 4 points in my survey, and it's going to take care of that for me. So now I've got all the lights exactly where they should be in my survey without having to do anything more than just calibrate. And we could have done this other ways. There are lots of ways to calibrate, but this is new, this ability to take a file right out of the CAD view and match a sequence of points from the CAD view to the drawing view and create the calibration that way.
Okay, pretty neat. So enough tools in there now for me to take one of these sort of disparate CAD files and bring it in exactly the way I want. And some of the videos we've seen earlier are also in the same topic about calibrating CAD. Okay, I just want to look here. So we're done with that third workflow, And I'm going to go back and just take a look. Okay, exporting specific objects to an existing CAD file. Okay, so we're updating that CAD file. Pretty neat. I like that. I'm going to take just a couple more minutes. I don't know that we'll get to 5 necessarily, but let's just take a real quick look at using LandXML for Civil 3D. LandXML is a data exchange language created just for Civil 3D, allowing other programs to share data with Civil 3D. So LandXML files exchange data with Civil 3D similarly to the way that DXF files exchange data with DWG files. The cool thing is they use HTML code, or XAML, to represent the data for the points, parcels, alignments, and surface. So it's actually readable. So here's the workflow. If you're doing contract work for a firm or agency that has adopted Civil 3D, you may want to submit both a CAD file and a LandXML file, allowing them to choose the one they want to work with. So let's just drop into here real quick, and we talk about LandXML. Now, LandXML is really neat in that the parcels and the alignments coordinate, line up real well with traverses. The points line up with traverse species points, and the surfaces come across. So there's just a real good correlation, a real good fit there. And this is just 3 minutes. Let's just drop in here real quick and give you an introduction to exporting to Civil 3D via LandXML.
In this video, we're going to write an entire survey to a LandXML file. Let's start with the survey we ended up with after we imported a LandXML file into Traverse PC. And I want you to notice that we have surfaces in here. Here I've turned on the existing surfaces. We've got these partial traverses that I can turn on or off just by tagging them. And I have these alignments. So let's turn those back on. And let's come over to the File menu and choose Export. We're not going to take a look at this right now, but I have the opportunity to export just pieces of the survey, just the parcels, just the alignments, just the points, just the surfaces, etc. But for now, I want to export the entire surface as a LandXML file. And let's just hit Export. Tell Traverse PC that we want to write it. And we see it's writing the points, writing our 2 surfaces, writing our 83 parcels, writing our 6 alignments, and it's finished. Now, if we were to preview that file, Traverse PC is going to open that for me in a browser. And I'm going to just bring that over here real quick so you can see that. And we're going to let this run just a minute so I can collapse some of these areas. But I want you to see, since these are basically readable files, that here are my units that I wrote. Here are the CG points, again with the name, the code, the coordinates. I'm going to see if I can collapse these for us. Here are my alignments that I wrote from Traverse PC. Here's the First Avenue. And if you remember from the previous video, we said there were some vertical curves in here. So here are the vertical curves for that alignment. Let's go ahead and collapse that one. Here's another alignment, Second Avenue, Third Avenue, so on. Here are the parcels. Here's Lot 1. And this is the geometry for it, including the curve information. Let's go ahead and collapse parcel Lot 1. Here's Lot 2, same thing. After the parcels, if I can collapse that for us, here are the surfaces. And again, Traverse PC includes all the geometry for those surfaces. Here are the points involved with it. Here are the faces involved with that. If that surface had included break lines, we would see the break lines here. Traverse PC does include the border edges in those 10 faces, so we're going to see that information. And then any other additional information that Traverse PC includes in this version or future versions can also be added to that LandXML file. And I can turn right around now and import this into any software that supports LandXML, in this case version 1.2. So any LandXML application has access to the points, alignments, parcels, and surfaces that Traverse PC created. The great thing about applications that support LandXML is that the data is rich enough in LandXML that they don't really care who created that surface. They have all the information they need about that surface.
Okay, so I just wanted you to get a real quick look at LandXML. we cover it in detail. Remember I said the points, parcels, alignments, and surfaces correlate really well with Traverse PC's data. So LandXML is a really good partner with Traverse PC for communicating with Civil 3D. And I'm not going to belabor that a whole bunch, but I just want you to know that that's our fourth workflow for exporting to CAD via that Civil 3D. Okay, I'm going to take just a few minutes more and let's drop down to our fifth workflow, which was exporting a CAD file to data collectors. So this is what we're talking about. In addition to exporting ASCII coordinates and geodetic positions to data collectors, many data collectors work directly now with CAD files. A lot of times we don't call them data collectors anymore, we call them field controllers. But here's the issue, and this is where the workflows come in. Depending on the screen size and processor speed, you may want to limit the amount of information that you export to that data collector. Now, keep in mind, like when I'm working on a file, I've got a 27-inch monitor off to the side, and that's where I put my drawing view, and I'm doing all my drafting there. I can zoom in and see things pretty close. The data collectors, although a lot of them are now Windows, or maybe they're a tablet, are still a pretty small screen. So it really helps for a number of reasons to think about, well, maybe we just reduce the file size to reduce the transfer and load times. Or maybe we reduce the layers, making it easier to select the needed layers in the field, so they're not going through all the proposal layers and whatever that they're not staking out. And then also we might want to reduce the area being sent, so it's easier to find the data for that day's work. So there's lots of reasons that we would want to modify or create a special CAD file for that data collector that wants CAD files. And really this fifth workflow is just kind of putting some of the pieces together so that we can get out to that data collector exactly what we want. So let's just drop in here real quick. And I want to talk real quickly about CAD export settings. So when I go to write these files, I have the opportunity of saying, hey, I want a DXF file, or I want a DWG file, or a DXB file, or a DGN. Okay, so I could send the type of file the data collector wants. I can select the version of that type, and I've got a lot of options in here that can simplify that data. We took a look earlier when we were talking about managing layers, about using these Traverse layer names and combining those with the entity layers to get that sort of richer, more stratified layer setup. And for field work, that can really help. So I've got just the proposed symbols, not the symbols for everything in the file. So it can really help just to be able to simplify those down a little bit. So that export settings dialog is going to be big in that. But you're going to have other considerations like exporting CAD to a data collector with or without calibration. A lot of you do field calibrations. So you set up on 3 or 4 points in the field, and as you collect the information, particularly with your GPS or GNSS, it actually calibrates that data to the GPS or GNSS signal. You can do that primarily with the RTK type stuff or the virtual reference stations. But you can also calibrate out of Traverse PC so that data collector gets exactly what it wants. Kind of a neat way. So you've got that choice to make. We talked earlier about exporting specific layers or entities to the data collector and why that would be important. And we cover all that just like we did earlier in exporting specific layers and objects to a one-off CAD file. I want to come back up here just for a moment though and say, what if your data collector doesn't read CAD files? And I'm just going to take a little side trail here. Traverse PC allows you to calibrate on import-export through a lot of the different file types. Most of your data collector file types, GIS, ASCII. You can do the same thing with calibrations for that data file, that we've been showing with the drawings. And we've got a little video here that is 6 minutes, and I know we're over already, but I think it's important to kind of take a look at this because you're familiar with this example now. And I want to show you that whether we're exporting a CAD file to our data collector or ASCII coordinates to our data collector, we've got the same options to make sure that we're sending over the data in the right coordinate system. So let's just take a look at this.
Let's take a quick look at using calibration when we import and export. I've got the CAD view opened here with a CAD drawing related to the survey I'm working on, but it's not on the same coordinate reference system as my survey. That's often the case. So I've actually inserted that XREF over here, and I created a calibration to lock it onto the coordinate reference system of my survey. And I created that calibration, and now I just uncalibrated so you could see what that difference was. Let's go ahead and take a look at this Plan 3373, and we're going to use that to export and import here. So here's that Plan 3373, and we can highlight it. You can see it's this sort of interior boundary of the right-of-way there. And I'm going to show you how this works. So let's go ahead and tell Traverse PC we want to export. And it really doesn't matter which option we choose. I'm going to choose ASCII here, but any type that supports calibration on import and export will give you this calibration button here. So initially it'll be set to none. I can just come in and select the calibration that I want. Here's the one I created earlier, and it just gives me a real quick reference here that it's going from the DWG to a local site, which is what happened. I went from the DWG reference system to my local site here for my survey. So I'm going to check that, but I'm going to check the reverse calibration because I want to export this interior boundary back to the coordinate reference system of the DWG. So I'm going to reverse that calibration. Let's go ahead and give this a name of whatever we want to call it. And I'm going to call it Plan 3373 text. And then I'll sometimes do this. I'll do the CAD CRS. So I know that the coordinates are in the coordinate reference system of the CAD file. And we'll just replace that. And let's tell it export. So we just exported those 9 points. And Traverse PC came into the message view and said, I'm going to tell you for each point here that I used this calibration from the local site, because I reversed it, to the DWG of the XREF, because I reversed it. So for every point it tells me I went from this coordinate to this coordinate. So from the local site to the CAD file. So if I were to import that now, and let's go to ASCII. And I'm going to make sure calibration is set to none because I want to bring it in uncalibrated. So in the coordinates of the DWG file, and it should lay that right over the top of this uncalibrated XREF. So let's just see if it does that. Here's that CAD CRS file. Let's go ahead and import that. And again, the message view tells me that I'm importing that, and it doesn't give me any calibration information because I didn't import it calibrated. So let's come over now to that Traverse. Here's what it imported right here, Plan 33 CAD CRS text. And when I check it, do you see where the points ended up? It plotted points on the uncalibrated XREF because those points are in the location or the coordinate reference system of the DWG file. So I could export this to the project manager, and he could simply bring that into his CAD file, and he'd have my coordinate positions. Now, I could add those to the file directly using the same reverse calibration. It's a real slick tool in Traverse PC. But I wanted you to see, have you see that if I exported those, that's what would happen. Now, let's go ahead and import this calibrated, okay, using the same calibration we use for the XREF to get us on our survey. So let's choose import, and I'm simply going to undo
what I had done previously. Gets rid of all that. Now let's choose our calibration. And we're going to use the same calibration, but we're not going to reverse it this time. And let's choose that file. So we're going to make sure we get the CAD CRS, and we're going to import it. And look what Traverse PC does. For every point that it just brought in, it says, I do have a calibration that I'm going to use, and I am going to calibrate that point from the point I read in the file to the calibrated position. But then it comes and says, oh, I already have a point at that calibrated position, which is what it should do. And so I'm not creating any new points. I'm simply reusing those points. So now when I come in and plot this new traverse that I got, I'm really just going to see it right over the top of what was already there. So I'm not changing any positions of my survey points. I'm saying I calibrated the uncalibrated or the CAD positions, and they exactly match my survey positions, which is exactly what I expected. Okay, so I can do this same operation with any file that supports calibration. So if I was going to do a land XML, for instance, I just choose the calibration because it supports it. If I choose a file type that doesn't support the calibration, this will go away, and I just simply won't see that option. So importing and exporting using calibration or reverse calibration so that I can reconcile the data I'm bringing in and sending out to whatever calibrated or uncalibrated coordinate reference system I want. Okay, I'm going to stop there. Let's drop back out now. I think we've covered kind of the issues involved with sending both CAD files and just ASCII coordinates out to our data collector with or without calibration. So I just want to drop back up to the top of this workflow and just to remind you that we asked these questions about how am I going to use the CAD file that I need to create or that I'm required to use for this project. And based on how I answer these questions, I'm likely to choose one of these 5 workflows. Now, you might have a workflow that's slightly different. Chances are you're going to use some of the exact same tools. And we just give you a great sort of jumping off point here by including these export workflows under the heading in the Unified Help System called Using CAD. Okay, thank you for joining us for our April webinar. Join us again in May, and we're going to take a look at CAD import workflows. We're going to do the same thing. We've got 6 of them instead of 5, and we're going to cover those just like we did in this webinar. So we'll see you in May.